A very good morning to everyone. My name is Singh and I am from APU IMechE Student Chapter. First of all, I would like to thank you all for being here today, and we are honored to have technologist Harvin Kaur for this tech talk on emulsion. Miss Harvin has obtained her chemical engineering degree from University Technology Petronas, and she has continued to pursue her masters at the same university. From there, she has worked with Kebangsaan Petroleum Operating Company and various other oil and gas companies for 5 years before starting her journey as a lecturer in APU. She is also a chartered engineer and a professional technologist, and currently she is in the midst of completing her PhD in the same university. And today, she will be sharing with us her point of view about emulsion and how these temporary stable mixtures behave in various phases. Without further ado, let's welcome Miss Harvin to start the talk. Miss Harvin?
Yeah. Hi, everyone. Good morning, good afternoon, good evening, good night, wherever you are. And today, my topic is on emulsion. Thank you for actually tuning in on a Saturday afternoon. I know you must be enjoying time with your family and friends, but nevertheless, let's just tune in for a little bit of knowledge for the next 1 hour plus. So a little bit of background on myself. My name is Harvin Kaur, and I've done my chemical engineering and master's in mechanical. So I'm also a chartered engineer with IMechE, and these are that's my email address and my handphone number if there's any queries after the talk. So my agenda for today is just a few things that I want to talk about emulsion. So first we'll talk about the oil and gas production in general, and then we'll scale it down to flow assurance, and then we'll scale it down even further to emulsions. So we will talk about emulsions, the risks, the causes, the creation of emulsion, the characterization, and also how to mitigate them. Okay, so in general, okay, oil and gas production. So what do you know about oil and gas production? Basically, oil and gas is the black gold that we want to achieve, or we want to get, or we want to extract from beneath the ground to actually serve a lot of purposes in terms of fueling your cars, or even anything that you touch sometimes is also made from petroleum. So oil and gas production is something very, very important that we must actually understand deep beneath it what happens. Yeah, so everything starts from the reservoir. Okay, what is a reservoir? Reservoir is an area, a place which is beneath the ground, that where we actually extract the oil and gas from. Okay, so hydrocarbons actually flows very naturally from the reservoir. All right, but however, some does not. When it does not, you need certain assistance to actually produce it over a life period circle. And of course, you need downhole pumping, you need boosting, you need gas lifts, you need all sorts of things to actually assist in production. Okay. So where does the oil and gas production end? Basically, it ends at the point of sale. When I mean sale, it means when you sell it. Yeah. So along the way, there's a lot of things that we need to consider. So there will always be a lot of pressure, temperature variance. There will also be, when you want to produce oil and gas, you produce other things as well, such as water. And not only water, another major issue is sand. So when you produce hydrocarbon in general, you can also produce sand, which that is also very important to tackle. But today we are going to tackle another different topic. Okay, so let's scale it down to flow assurance. So flow assurance is actually a Portuguese term called Garantia do Escoamento. Yeah, so that means flow assurance. Yeah, so this has also been developed by Petrobras, is the national oil company of Brazil, in the early 1990s. So what does it mean? It means guarantee of flow. You want to guarantee a flow. So the term flow refers to the hydrocarbon stream from the reservoir right up to the point of sale. Therefore, it covers different disciplines, one subsurface and one surface. When I mean subsurface, everything beneath the seabed. Surface is, of course, what you see. Okay. So what is flow assurance? Flow assurance is a technical discipline that actually guarantees achievement of a lifting and transport system's lifetime production targets. That means you want to achieve your targets of production. So if you have set a target, you want to ensure that you achieve it. When you achieve it, that is what you need to call flow assurance. You need to assure the flow. Yeah. So from the near wellbore to the point of sale is where we take care, the flow assurance. Yeah. So you do predicting, you do preventing, you do solving problems, which originates basically by transporting these substances. Right. So these substances can also be called gases, liquids, solids, or whatever that you're producing. Right. And they come in multi-phase flows. So there are quite a bit of issues on flow assurance, so such as hydrates, wax, emulsion, slugging, scale, erosion, corrosion, and so on and so forth. But today we're going to tackle emulsion. So flow assurance scope, you ensure a production system is specified to achieve four things. One, deliverability. You need to ensure that your pipeline or your production pipeline or your platform, for example, you need to know that you can deliver. All right. So achieving production targets are very important. Whether you boost, you lift, you size your equipment, that is entirely up to the engineers and, of course, economically justified. The second thing is restriction free. You want to ensure that you can move your oil or gas from point A to point B. That means from your reservoir right up to the point of sale. But you want to ensure that you don't have restrictions for it. Okay, so restrictions can come in hydrates, wax, and so on and so forth. So you want to make sure that you don't have all those. All right. The third thing is integrity. You need to make sure that whatever that you're doing, your corrosion, your pipelines, and so on and so forth, they do not fail. So integrity is something very important that you need to tackle. And the last one is controllability. How do you control something that is already happening? For example, you are producing your oil and gas and you start to see a bit of slugging. Yeah, so that slugging, you need to actually be able to produce a stable and flexible operation for your particular field. Okay, so flow assurance is actually a bridge between subsurface and surface. So we are the middle guys. Okay, typically it balances out the inputs from the reservoir with the demands and constraints from downstream. All right, an aspect of a design process that leads to system design and system operability. So basically you need to design and operate your system according to how you want to mitigate your flow assurance issues. Okay. Now let's talk about emulsion. So what is emulsion? Emulsion is a thermodynamically very unstable system that consists of two liquids which are immiscible. Yeah, so one liquid is actually the dispersed phase and the other liquid is actually a continuous phase. When I say dispersed phase, it means in terms of globules. Yeah, they come in very small globules. And the other liquid is in continuous phase. That means it is present there throughout. And emulsion is also stabilized by the presence of an emulsifying agent. You need an emulsifying agent to actually produce an emulsion. So what are emulsions? If you look at the picture on the left, that is an actual emulsion. So if you see, there are three phases there you can see. The top one is oil, the right at the bottom is water. But what happens in the middle? In the middle is actually called emulsion. That is the phase that cannot be separated. They are quite stable. Yeah. So an emulsion is a dispersion, again I mentioned, of one liquid in another liquid. All right, immiscible liquid in another immiscible liquid. Yeah. So one is a dispersed phase, one is a continuous phase. The second point is, for produced oil field emulsions, one liquid should be aqueous and the other should be crude oil. Therefore, the most common one in oil and gas is actually water and oil. Yeah. And the last point is, the amount of water that emulsifies with crude oil actually varies from less than 1% to greater than 80%. Okay, so the emulsion range can really be very wide. Okay. Types of emulsion, right? Types of emulsion, basically there are actually two main categories, but there are four types. Okay, so the first one is the water in oil emulsion, which is shown on the screen. And the second one is the oil and water emulsion. So when I say water in oil, water is the dispersed phase, oil is the continuous phase. That means there are water globules in the oil. Or if it's oil in water, there is oil globules in water phase. So the water is the continuous phase. The second part is the complex multiple emulsions. So over here we have two types. We have water in water emulsion, and we have oil in water in oil emulsion. So these are the more complex versions of emulsions. Like I've mentioned in the previous slide, this is just a description of all the emulsions. So one liquid phase in an emulsion is essentially polar, which is aqueous, while the other one is actually non-polar. Usually it is crude oil. So the types of emulsion, again, oil in water, when the oil phase is dispersed as globules throughout the aqueous phase, the system is referred to an oil in water emulsion. But if it's the other way around, water in oil emulsion, when the oil phase serves as a continuous phase, the emulsion is actually termed as water in oil emulsion. And multiple, these emulsions whose dispersed phase contains droplets of the other phase. So for example, if you have water in oil in water emulsion, you know that water is your continuous phase. On top of that, you have globules of oil phases, and inside those globules of oil phases, you actually have small water droplets. So those are actually multiple complex emulsions. Why is there emulsion? Emulsion is such a big problem. Why is there emulsion? So crude oil is seldom produced alone because it generally is commingled with water. Okay, you cannot control what comes out, right? So basically, they are actually commingled together. So produced water may be produced as free water. That means the water that will settle out very rapidly, or it may be produced in the form of an emulsion. So there are also advantages to emulsions. Do you know that lotions or creams are actually emulsions? So these are actually complex emulsions which are very stable. Okay, so that is also called an advantage that you have for emulsions. Okay, now brings me to where do emulsions actually happen? So there are a few places. If you see in the diagram, you will see the reservoir up to the surface facilities, up to the from the reservoir right up to the riser and all that, and then it goes to the surface facility. So there are a few places where emulsions actually occur. Sometimes, most of the time, actually, it occurs in the reservoir itself. All right, and then once it goes up into the surface facilities, of course the surface facilities like separators will have some emulsion because the liquids are coming out at a very high velocity. What are the risks of emulsion? Okay, so emulsions are actually very difficult to treat, and they actually can cause a lot of operational issues, including money. It takes a lot of money to actually treat emulsions. Okay, so emulsions can be very difficult to treat and may cause several operational problems, such as handling facilities. Do not forget, when you produce an emulsion, you are actually wasting, So therefore, they have separation facilities to actually separate the emulsion, which costs money, but nevertheless, you are trying to raise your production rates. Okay, so the presence of emulsions actually, there are a few points to this. So one, it creates high pressure drops in flow lines. So for example, if you want to move something from point A to point B, you need to move from high pressure to low pressure, correct? So when you move from high pressure to low pressure, there is a certain pressure drop that you need to actually push something up, right? So when your oil or gas comes out from the ground, you are actually, emulsions actually occur in oil reservoirs mostly. Okay, so when the particular fluid wants to come out, or when there's emulsion that has already occurred, you need a higher pressure drop to actually push it out. So that higher pressure drop will actually incur a lot more things. You reduce your production rates, your cost increases. There's a lot of things that is depending on that, which also your separating facilities take a longer time, and so on and so forth. So the second one is leads to an increase in demulsifier use. Of course, there are demulsifiers in the market to actually separate off emulsion, which are all chemically stabilized emulsions. Okay. The third one is sometimes it causes trips or upsets in handling facilities. When you produce emulsions, do not forget, when you produce oil with water, water is an agent to actually cause corrosion in the pipelines. Yeah, so it can actually cause a lot of upsets in the handling facilities. The last one is results in corrosion, like I've mentioned earlier, results in corrosion and catalyst poisoning in downstream processing facilities. So emulsion is a very huge problem when it comes in the industry. Causes of emulsion. Basically, high water content is due to, one, poor cementing done, poor reservoir management, and poor operating practices. So, for example, you produce too much of water, or your flow is too turbulent. Excess turbulence in the flow will actually cause the oil and water to agitate. When it agitates, it actually mixes together. Yeah, and then it starts to coalesce together, and then that will create emulsions. These are some pictures of emulsion. So for example, let's look from the left to the right. Yeah, so from the left you can see a very stable emulsion because it has gone through mixing. The next picture, the droplets get the separation starts to happen very slowly, but it's happening. If you look at the next picture, there is already a layer of oil on top. That means there is also a what you call that, the separation has already done. And the last one, of course, you can already see the layer of oil. So there is a distinguished layer there between oil, water, and also the emulsion layer. So the middle one is actually the emulsion layer, because emulsions are actually heavier than oil but lighter than water. All right. So how are emulsions created? All right. So crude oil emulsions form when oil and water come into contact with each other, when there is sufficient mixing, or when there is an agent of emulsifying agent present, it will cause an emulsion. So if you look at the picture over there, you can see the oil and water phase, and then you start seeing the coalescing, the mixing and the coalescing of the emulsions. You will have unstable emulsions, but the more it coalesces, the more it agitates, you will actually get a stable water in oil emulsion. How are emulsions created? So this is where the mixing comes in. So the greater the mixing, the smaller the droplets of water dispersed in the oil, and the tighter the emulsion will become. So after this talk, please go to the kitchen, take some water, take some oil, and put it in a bottle and start mixing it. The more you mix it, you will notice that the droplets become smaller and smaller. So when it becomes smaller and smaller, there will be a tighter emulsion. So sources of mixing, but you must understand that when we talk about oil and water, crude oil specifically, when you agitate, there are certain things present in that crude oil, some certain properties, that components that are present in the crude oil, that also helps to stabilize the emulsion. All right. Sources of mixing. One, flow through the reservoir rock. So when the oil flows through the reservoir rock, it tends to get mixed with the other things there, such as water. We have a lot of drilling mud that's been there, that kind of thing. So basically, they actually tend to get agitated. When they get agitated, they mix, they actually form a emulsion. The second one is bottom hole perforation. So at the perforation itself, you can also have the emulsion happening because there is mixing there. Flow through the tubing, flow lines, and production headers. So all those, whenever you have a high velocity, you will see an emulsion. Valves, fittings, chokes, those are restrictions. So whenever you have restrictions, you definitely will see some emulsion because there is an upset in that system. Surface equipment such as separators, you will see certain emulsions happening. And gas bubbles that are released because of phase changes also will actually contribute to emulsion creation. The next point on how is emulsion created, it's also by the emulsifying agent or the emulsifier itself. So the presence or amount and nature of the emulsifier actually determines a large extent the type and the tightness of the emulsion. So the more you mix, the tighter the emulsion. The more emulsifiers you put inside your to emulsify something, the tighter the emulsion. Crude oil with small amounts of emulsifier forms a less stable emulsion, and that separates very easily. Other crudes contain the right type and amount of emulsifiers, which leads to very stable and tight emulsions. So again, the more you mix it, the tighter the emulsion, the more stable it is. Emulsifiers can be surface active agents or even finely divided solids. So there are a lot of things, components, for example, in the crude oil that actually contributes to emulsification. Now, surface active agents such as surfactants are actually compounds that are partly soluble in both water and oil. You know, when we were in high school, we learned hydrophobic and hydrophilic, right? So this is where it comes into play when we talk about emulsification. So naturally occurring surfactants in the crude oil, like I mentioned earlier, there are certain components in the crude oil that actually contributes to emulsification, which are asphaltene resins, organic acids, and of course, bases. Other surfactants that may be present are from the chemicals injected wellbores. So, for example, you have drilling fluids, you have stimulation chemicals, you have corrosion inhibitors, scale inhibitors, wax, asphaltene, and so on and so forth. So there are many things that actually help stabilize an emulsion. Another emulsifying agent is the finely divided solids. So fine solids here are actually mechanical stabilizers. So these particles are actually smaller than emulsion droplets, and usually they are in very submicron sizes. They are collected at the oil-water interface and are wetted by both oil and water. So the effectiveness of these solids in stabilizing emulsions depends on a few factors. One is your particle size. When I say particle size, it means those tiny droplet particle size that are going to stabilize your emulsion. That's one. Number two, the interparticle interactions. You know, you have the interfacial layer. That is very important to know because those are the things that are actually going to stabilize your emulsion. Next, finely divided solids are actually found in oil production, which includes you have clay particles, I mentioned earlier, sand, silt, and also asphaltene and waxes. So probably next time we will have another talk on asphaltenes and waxes after this emulsion talk. Yeah? Okay. So when we talk about types of emulsion, you remember there are two main categories, oil in water and water in oil, but we have four types of emulsion. Yeah, because we also have the complex multiple emulsions. Okay, but emulsions are actually classified by the size of the droplet in the continuous phase. That means if you have oil in water, your water is a continuous phase, your oil droplets are the dispersed phase, that is oil in water. Those oil droplets are actually that will actually classify the emulsion type because of the size of the droplets itself. So for example, we have two types, macro emulsion, micro emulsion. So macro emulsion, most oil field emulsions actually belong to this category. Okay, when the dispersed droplets are larger than 0.1 micrometer, that is very, very small. Yeah, so emulsions of this kind are normally thermodynamically unstable. So they are unstable. When I say unstable, those two phases will actually separate over time because of the tendency of the emulsion to reduce the interfacial energy by coalescence and separation. So because the droplets, like I mentioned, the more you mix, the smaller the droplets, the tighter the emulsion. But here, macro emulsion, if your droplet size is not that small, of course, it is small, but it's not that small, therefore it is unstable. So when I mean unstable, the two phases will actually separate over time because there are a few things that happen before an emulsion creation. Those things are actually the energy, the interfacial energy inside that is not good enough. Therefore, the emulsion separates easily. But macro emulsion is a very big thing in the industry. Droplet coalescence can be reduced or even eliminated through a stabilization mechanism. So there is a stabilization mechanism that will actually help coalesce and create the emulsion. Okay, so the second point is here is the micro emulsion. So these are the very small droplet sizes which are less than 10 nanometers and are considered very thermodynamically stable. Why? Because you can't see them with the naked eye. Right? So these emulsions form spontaneously when two immiscible phases are brought together. Why? Because of their very low interfacial energy. So due to the interfacial layer, the energy in the interfacial layer is very low and the droplet sizes are very small. They actually are very stable emulsions. So micro emulsions are fundamentally different from macro in their formation and stability. Now, let's talk about droplet size. Since we spoke about micro and micro emulsions, let's talk about droplet size. So, droplet size distribution in an emulsion, it also determines to a certain extent the stability of it. Okay, so tell me, based on the slide previously, macro is more stable or micro is more stable? Definitely micro, because the emulsion droplets are smaller. Okay, so to a certain extent, droplet size plays a very major role in the stability of the emulsion. The droplet size distribution in an emulsion depends on a few factors, which includes one, interfacial tension. What do you mean by interfacial tension? It is the layer in between the oil and the water, the layer in between that causes the tension between both, that is the interfacial tension. Interfacial tension is where we know how big the droplet size is and we know how stable the emulsion is from the interfacial tension itself. Two, shear. When I talk about shear is how can I shear my emulsion. So for example, when you shear something, you are actually agitating something. Therefore, it actually creates a smaller droplet size, which creates emulsion. The third point, nature and amount of emulsifying agents. So the amount of emulsifying agents in that particular crude oil will actually help us understand how tighter the emulsion will be or how stable the emulsion will be. Number four, the presence of solids. The components of solids that are actually present in the crude oil itself will actually help us determine the stability of the emulsion. And the last point is the bulk properties of oil and water. That means what are the properties of the oil or what are the properties of the water? When I speak about water here, I'm not talking about the normal water that we drink. I'm talking about the reservoir formation water, which has precipitated salts, which has a certain level, pH level, and so on and so forth. So those are the properties that we need to take into account, which also helps us understand the stability of the emulsion itself. So the last point here, the smaller the average size of the dispersed water droplets, the tighter the emulsion and therefore the longer the residence time required in the separator, which implies larger separating plant equipment sizes. Not only that, more money. All right. So the smaller the average sizes of the dispersed water droplets, the tighter the emulsion. So therefore, the smaller the droplets, the tighter the emulsion. Right. Okay. So the stability mechanism of an emulsion has to go through four processes. Sometimes it skips a process, but nevertheless, let me explain to you all the 4 processes. So the stability mechanism has got the first mechanism, the first process is the creaming or the sedimentation. This is where the driving force is actually gravity. When you mix oil and water, naturally water will go down, oil will go up because water is heavier than oil. Number 2, flocculation. So this is due to the polydispersity and Brownian motion within the oil and water phase. Third, Oswald ripening. So the driving force of this is the pressure differential between the small and the larger droplets. This is where the macro and micro emulsions play a role. Of course, not only that, the solubility of it and the viscosity of it. Okay, everyone. So tell me, what is viscosity? Viscosity is the resistance to flow of a particular phase. So for example, oil or water, what is the viscosity? That also plays a very major role in understanding the stability mechanism of a emulsion. And the last one is the coalescence. When I talk about coalescence, it's basically all the small droplets that coalesce together, they form bigger droplets. So these are actually where the film gets thinning or ruptures, or even the droplet gets fused, So they actually commingle together to actually form emulsions. Okay. How do you characterize an emulsion? The most common method to characterize an emulsion stability, to understand emulsion stability, is the bottle test. All right. So when you do an emulsion, you create an emulsion, you put it through a homogenizer, you mix it at a certain RPM for a certain duration of time at a specific temperature, you will create an emulsion. Immediately upon mixing, you pour it into a bottle test to understand the separation mechanism, whether it separates, whether it does not separate, what happens, what phases, what are all these 4 phases actually going through. Yeah, sorry, my bad. Okay, so the most common method to test is the emulsion stability is the bottle test. It is used, 1, to determine severity of emulsion by monitoring the water separation over time. That means you want to see how the water separates from the oil. Second, to determine the water separation from the demulsifier dosage. So sometimes when you pour in the demulsifier to actually show the emulsion separation, the demulsifier also will separate from the water. So you can actually see the dosage of the demulsifier. That's 2. Number 3, to screen demulsifiers. To understand which demulsifier you want to use for your particular field, sometimes they even use bottle testing. All right. So there is a picture over there on what a bottle test looks like. What are the factors that affect emulsion characteristics? So the emulsion characteristics also change when the liquid is subjected to the following. Temperature. Okay. How does temperature actually affect emulsion characteristics? Basically, in the reservoir, our temperatures are quite high. So when they are at high temperatures, you actually are you should not be what would I say, the emulsions created would actually be less tighter, but the moment it comes out, because it's in a different condition, the temperature is lower, the emulsion gets if the crude oil is very waxy, it tends to go into a solid phase. So basically temperatures play a very, very important role. All right. Pressure. Why does pressure get involved in emulsion? Because again, high pressure, high temperature reservoirs, certain reservoirs such as waxy reservoirs and all that, these are all very stable. They produce very stable emulsions. And the last one is the degree of agitation. Again, how much you mix. All right. Okay. Mitigation of emulsion. Right. So 1, prevent having a choke or control valve before water separation. Number 2, maintain plunger, rod pumps and valves. These are all basically things that we can use to assist in creating a better production rate. Number 3, centrifugal pumps without a downstream throttling valve will actually help mitigate emulsions. Whenever possible, opt for cavity pumps reciprocating pumps, and gear pumps. Next, optimizing a gas lift. And the last one, optimizing production at an integrated asset level. So emulsions can actually be mitigated provided that you know the components, the composition of the crude oil itself for you to have a, they say prevention is better than cure, right? So basically to prevent an emulsion from actually occurring, right? Okay, so what we have gone through so far, we have understood what oil and gas production is. We have understood what does flow assurance mean and how important it is in our industry. And then we have scaled it down further to actually emulsion. So we understand what are emulsions, what are the types of emulsions, how do they actually form, why do they actually form, what are the risks emulsions create, and of course, how to actually mitigate an emulsion, how to remove an emulsion. So those are actually very important things to note for all of us. So therefore, I would like to conclude my presentation today. Thank you very much and looking forward to seeing you probably at our next section.
All right, so right now we'll be having our Q&A sections. So we got a question from Leon. So the question is, what are the factors that affect emulsion formation and stability?
Sorry, repeat that again. What are the
What?
factors that affect emulsion formation and stability? Okay, there
Yes.
are a few factors. One is temperature, pressure, how do you mitigate basically the mixing, the agitation, and of course understanding the particle or droplet sizes in the particular emulsion.
Another follow-up question is there possible to make oil and water to mix for a last longer period, more than a month or a year?
um, Oil and water to mix for a longer period. Definitely. Like I said, if the emulsion is very stable, so for example, if you mix to create an emulsion and then you put it into a bottle test and you want it to last for basically a year, once the emulsion is stable and it has reached all the four phases, it goes into the stability is very, very high. Therefore, it will last for however long until you put in a demulsifier. Yeah.
Another question is from Sabrina. So how do oil field emulsions impact crude oil productions?
Okay. Oil field emulsions, they actually hinder a lot of crude oil production because basically the emulsion is the immiscible thing between oil and water. So they actually are how would I say, they are actually commingled together. So when they are commingled together, neither you have oil, neither you have water, but you have a substance that you cannot really be called production. So basically, oil field emulsions, they impact to there's a statistics about 20 to actually 30%, which it hinders production. Yeah. Thank you, Sabrina, for the question. Yeah.
Another question from AR June. So is centrifugation used to separate oil and water, and if so, is it a difficult process?
Centrifuge. When you use a centrifuge, usually you cannot really use a centrifuge to separate oil and water because they are of a different phase, but they use centrifuge to actually separate out sand. So sand is quite important to also eliminate besides emulsion. So usually they use a centrifuge, but usually for oil and water, not so. They actually just pour in a demulsifier, a chemical demulsifier, but definitely you need to know that the chemical demulsifier will not hinder the process facilities and will not hinder what you call that. One is the process facilities, and of course not hinder the properties of the crude oil that you're producing. Yeah.
Next question is from Dr. Arun. So emulsions are formed due to mixing of oil and oil with water. Then how gas contributes to formation of emulsions?
Okay. When you have gas droplets, okay, I will share on that part first. When you have gas droplets are actually entrapped. So when they are entrapped, they actually they don't assist in emulsion creation, but they actually help make it more stable because of the encapsulation of the molecules. That's one. Number two, usually oil, when you have oil production related problems, they are usually emulsions, wax, asphaltenes, and so on and so forth. In gas, on the other hand, when you talk about gas usually contributes to something called hydrates. So that is the emulsion on the gas side. Yeah.
Okay. Manshika has a question. And does environmental parameters such as temperature affect emulsion?
Yes, definitely, because temperature will affect viscosity. So basically, the higher the temperature, the lower the viscosity. So when something is in low viscosity, it is not resistant to flow. It flows very easily. But when your temperature is lower, for example, if your components in that particular crude oil it's very solid, it looks very solid in normal ambient temperatures, for sure if you have something in lower temperature, the viscosity is very high. Therefore, if the viscosity is very high, the pressure drop to actually move it is also very high. So definitely it will affect emulsion.
It's another question from Leon. How can Mactel oxide be used to stabilize an emulsion?
Okay, this is a very interesting question. Thank you, Leon. So metal oxides actually have certain properties inside it. Okay, they have certain components or compositions inside metal oxides which actually contributes to the emulsion stability. In order for us to know that if we have certain type of emulsions in the pipeline, we need to design our equipment uh, so that it does not cater or it does not contribute to the emulsion stability. So the components inside it is the one that creates, that helps stabilize the emulsion.
So Harris has a question. So is there an optimal temperature for emulsion, or does it depend on different situations?
Okay. Thank you, Harris. Okay, so the optimal temperature, there's no specific optimal temperature for emulsion, but usually when it occurs in the reservoir, definitely it will be reservoir temperature. For example, 80 degrees C to 90 degrees C. So therefore, even if the emulsion occurs at that temperature, can you imagine when it comes out what problems it can actually cause? So there's no specific optimal temperature because you can even have emulsions. It depends on your crude oil. Your crude oil, they have um, light crude oil, medium, heavy, waxy, and so on and so forth. So it also depends on the type of crude oil that you are actually dealing with. So the optimal temperature would normally be would depend on that, the type of crude oil. So if you're talking about emulsion creation, no, there's no specific optimal temperature. But usually it's in the reservoir, so basically it's reservoir temperature.
Okay, we have another question from Farhan. So the emulsifier is used to eliminate emulsion. Yet, what would be the contributions of pressure and temperature in regards to this situation? Should we increase or decrease temperature? or the pressure?
Okay. Thank you, Farhan. There is no specific per se to increase or decrease temperature. Definitely, if you want something more liquid, then you put it at a higher temperature. So in terms of pressure, we are looking at the drawdown between the reservoir temperature to the bottom hole temperature. So we should actually be bothered more about that when we talk about pressures. But in temperatures, when we have something at a higher temperature, we have lower viscosity. So we should aim for something like that. Therefore, even for gas in gas fields, when you have hydrates, you need to ensure that your well is actually warm enough so that it doesn't actually contribute to the hydrate formation. Something like that. Yeah. So temperatures and pressures actually play a very, very important role. Yeah, but it depends on field to field. Yeah. Right.
Another question from Leung again. Do we have catalysts for emulsion, and how do it work?
Okay. When you say catalyst, you want to produce an emulsion. Definitely, there are a lot of emulsifying agents that you can actually use to, one of it is the component in the crude oil itself, like asphaltene or resins. Those are actually catalysts to actually form emulsions. But if you're talking about a catalyst or a chemical to demulsify something, yeah, there are a lot of chemical demulsifiers available that you actually need to know the dosage, and it depends on the properties of your crude oil to actually put in order for you to break an emulsion.
Question from Fahan. In regard to well tests, we must have choke and regulate pressure due to equi limitations. What would be the best prevention mitigation method to be implemented? US stroke choke.
Okay. What would be the best prevention mitigation method to be implemented upstream choke? Okay. Like I said, chokes are actually restrictions in the pipelines, but nevertheless, chokes are necessary. Therefore, I would rather you mitigate the emulsion rather than mitigating an equipment. So a choke is actually necessary because it behaves like a valve. You open the choke and the flow, but you close the choke, it doesn't flow. So basically, we rather mitigate or prevent an emulsion from occurring rather than actually be worried about the choke or the other fittings in the pipelines. Yeah.
So
Is the
Mashika asks, is the process of separating oil and water environmental friendly?
Yes, thank you, Manchika. Yes, it is environmentally friendly, but of course, there are a lot of chemicals, certain chemicals, which are within environmental measures to actually, we have to take good environmental measures. So basically, we have certain guidelines in the fields. We actually have certain guidelines of how much chemicals that we can use to do separation. So we need to make sure that we are bounded by that guideline so that we do not exceed or we do not harm the environment. Yes, definitely.
So that's all for this Q&A section. Uh, Thank you for your attention. We have reached the end of this Tech Talk.
Thank you very, very
And
much.
yeah, please provide us your feedback about this Tech Talk with uh, with the QR code shown or the link provided in the comment section. Once again, let's thank Miss Harvin for the amazing Tech Talk, and thank you all for joining us today.
My pleasure, and thank you very much for tuning in today.